Hello, hi. My name is Lav Kumar. So today we are going to learn about the decision tree, one of the machine learning algorithm. So people are generally struggle to understand the what is the concept behind the working functionality of the decision tree. So I tried to explain this with simple terminology with clear explanation by using the PPT. So quickly share my screen and yeah. So decision tree is the one of the machine learning algorithm. So people are using this one like anything. Let's start. Yes, what exactly I'm going to explain here is, so first of all, what is the decision tree? So I'm going to explain about this one and what are the key terminology belongs to this. See, whenever you want to learn anything, so you need to have a clarity about what is the terminology used there. If you have clarity on this, no, then you can clearly understand the complex concept. And I'm going to give the one simple example and how the decision tree it will be splitting. So what are the different criteria are there? I'm going through the detailedly and how this decision tree algorithm will be working step by step and the live coding. So I'm giving the simple showing the Python coding also here and I'm showing the how the tree will be splitting on my given data and also what are the pros and cons also I'm going to explain here. So before going to this, what exactly the meaning of the decision? So in our real life also we will take the lot of decisions, right? So let's say we want to go for the Goa as a group of people, your friends. So what you are going to do is you guys are spend some amount. So first you guys are deciding, right? So the decision will be taken based on the how many people are there. Okay. And not only that, the money is one of the important criteria. And which route you are taking. So money is set, everything is fine. So which route you are going to take? By flight or the train or the bike or the car. So that is completely your decision. So that is the way you are reaching your endpoint and enjoying the vacation, right? So in the similar fashion, the decision tree is like a looking like a let's say people are taking the same concept how you're taking the decisions. Let's say after your study, where to go, which part you are choosing, going for the doing the business or the job. So the similar way, so based on the different factors, the decision will be you are taken in your life. So the same way we are taking the decision by the machine in the tree manner. Let's see what exactly the meaning of the decision tree. So the short way. So let's say it's a supervised machine learning algorithm and it is used for the both classification data and the regression task. So definition wise, it's look like it's a temple tree structure and the nodes means where exactly the splitting will be happening. So, so let's say trees are generally look like this, right? And it have the branches, sub branches, and the end point is the leaves are there. So in the similar fashion, we're calling this part as a node. Okay. So, so it's look like a tree structure and where nodes represent the decisions and the branches are the conditions and the endpoint with the leaf did show the final prediction. Okay. So completely looking like a tree structure and it is completely having the so nodes are there and the branches are there. How the tree is having the trunk and the sub trunks, the sub and the branches, sub branches, and endpoint is a leaf. Similar way, here also the decision tree will do the same. So these guys are the so decision trees are the popular because they are the simple and easy to understand. Let's see I will take a simple example. Let's say we'll try to explain through this example. So it's a rainy season. In generally in rainy season, what happen is we'll decide is it good time to go outside or not. So let's say it's an emergency. What you guys are doing? You will check is there any rain is coming or very. So let's say there is no rain, but the time what you can check for this, yeah, clouds are there. Is it high windy is there? We will check all these things, right? Check the windy. So if it is not raining, you will don't take carry the any umbrella. But if it is windy and it is cloudy also, you decide. So if it is high windy, what you can do is you will take the light umbrella. That's very important. Otherwise, you will go on. So your umbrella will go on up, right? So otherwise, so there is no windy. Then you can take the big umbrella. That is fine. You can easily carry. So how you can make this one is, so generally the decision tree look like it's a trunk, the tree trunk, and it is actually a reversing of your tree. These are the, let's say, branches, and it have the sub branches and it have the leaves. So the branches and the sub branches and endpoints with the leaves, these are the way the complete tree have. It is looking like a just reversing the tree. Okay, so this is the way it is going with the yes or no questions. Okay, let's see with a simple example. So the basically decision tree is the first we will understand the what are the different terminologies are there in the decision tree. The terminologies are like a root node, the root node, and the, you can say, parent node also. Means first you will take the complete data here, complete whatever the data, CSV or Excel, you will take it here. And after that, you will make the division and taking the some feature into the importance, and this is the decision node. You will take the decision nodes, and after that, the endpoint is the leaf node. So what, what exactly you're saying? So means, so the tree is reversing now, and you're first giving the complete data, then in that data we have the lot of columns. So those are slowly making the division. How these divisions? Before going to that divisions, so try to understand this, what exactly meaning of the root node and the decision node and the leaf node. Let's see the terminology. The root node is nothing but the top of the tree. It represents the entire data set we are putting here. Okay. Then you will start splitting, right? So complete data set is here. Let's say it's a CSV or Excel. Complete data set is here. Now we are splitting, right? Splitting like a division. You are dividing the complete data set. You are more sub nodes, right? But what exactly this decision node is? It's like a internal nodes. It have the splits. Wherever the you're making the splits, further splits, that is you can call it as the decision node. And after that, the endpoint you are already observed, right? So here you may observe the features of the CSV file. In the CSV file, you have the rows and the columns, right? So you can observe the different features. Okay. And endpoint, you can observe the result. The result means it's the prediction and the output. So whatever the output you want to get it, that is the output you can observe here. Let's say the particular person is eligible for the loan or not, right? The eligibility of the loan. So here you can observe the eligibility, yes or no. You can observe the yes or no's here. Okay, that's the end one, right? That's super. So, and the branches and the sub branches in the trees, you can observe the sometimes the lot of sub branches also existing. It have the multiple features are existing in the decision node. That is, you can call it as a sub branch. and pruning. Okay, these all terminology is fine. So root node where you are putting all the complete data and you are splitting, and the decision node is like you are making the decision about your feature, and branch nodes it may have the more features, and endpoint is you can call it as the terminal node or leaf node. What exactly this pruning is? Sometimes unnecessary branches are there. In the real trees also, what we are doing, we will cut down the some unnecessary branches, right? So that cutting also we can do here. So the cutting procedure you can call it as a pruning. Okay. Yeah. Let me explain the with one example. So we'll take one simple real time scenarios. Okay, I will take this guy is a Sham. So he generally based on the weather, he wanna decide go for the play the tennis or not. So let's see how decision tree will be working on this data set, and to predict this guys is playing or not. Let's see, let's try to understand the data first. So I have these features, the day and the weather. So this guy is so intelligent, huh? The temperature and the humidity is there. And I will consider the wind also. And this is my target because this is my result. So this is what I can see in the leaf node, right? These all are in the sub branches or the decision nodes. These all are visible, but these thing you can observe in the last part, the terminal node or the leaf node. So this guy, we can observe, see here the sunny, and if it is hot, the humidity is high, the wind is very weak, this guy is not going to play. He decided like that because uh, what is the tennis happen is with the tennis, the airflow must be very slow. Otherwise, you can't play. Okay, that's the reason this guy don't want to play. So in the sunny, you will get the more sweat and easily getting tired, right? So if it is cloudy and it's hot and high week, yes, he gonna play. And if it is sunny and the mild temperature and the humidity is normal and the wind is strong also, he wanna play. That's fine. So this is the way he prepared a chart and he want to give it to the decision tree. So the decision tree, what it does is first it will learn from this data, right? So let's say he is giving, so the complete data set is, it is like a root node. It's a weather. I'm putting the complete data set is here. And after that, it is make the splitting. So you can observe there are in the weather, you can see three things are there, main the sunny and the cloudy and the rainy. Three things are there. So if it is summer, it's a sunny. So he is going to be take one decision. Let's say it's a cloudy. It's a cloudy directly, he is gonna to play the tennis. That's not an issue. So if it is rainy, he is going to be consider the wind also. And based on that, if it is a strong wind, he is not going to play. If it is weak, yes, he is going to play. That's really interesting. And see here, you can see the complete thing will be the splitting will be happening based on this complete data set only. Okay. So here the humidity, and after if it is sunny, humidity also taken into consideration. This tree will consider that one also. And that if it is high, he is not going to play. If it is normal, yeah, he is happily going to play. See here, all the greens are leaf nodes, and these are the branches, and the internal nodes are the decision nodes. So this is the way the decision tree will train the complete data set. Fine. Let's say tomorrow he is giving this some information to this decision tree. Let's say this is my algorithm. This is my algorithm. I have already trained this algorithm. And this time I want to give the input, weather input. So based on that, I will decide. So now I'm creating my own machine based on my previous data set. So it is giving the result. Is it good to play or not? So then I will play. Otherwise, the sham will not play. Okay. So Here I will give the weather and I will give the temperature, even I'm giving the humidity and I will give the wind also. After that, it is giving the yes or no. Then I will decide. Okay, let's see. Okay, okay, fine, Laura, fine. But why the this decision tree take this weather only, take it as the first feature? Why not wind? Why not humidity? Why how this splitting will be happening? What exactly the procedure will followed by the decision tree is the algorithm. So there are the how does the tree will decide to split and which factor is or which feature, which column is the more important to me. Okay, so there are the different steps are there. One is the different methodologies are there. One is the information gain, and another one is the Guinea impurity. Oh, let's see each and everything very in detail. So, so it's a very strategic split is happening because we have a lot of columns and rows, and it is not easy to do the by observing or by watching. So even understanding to the machine also, that's a tedious task. So that's the why the people create this kind of things like a information gain and the Guinea impurity. And based on these methodologies, they are going to make the splitting. Which feature is I want to consider first on the top? What is the next? What is the next one? What is the next one? And end with the my leaf node, the result. And then based on this, I will completely finish the training and after that I will give the input. Let's see. Okay. Yeah. So what exactly this information gain? First, we will see this information gain. We'll try to understand this. I am going down. Okay, now. Yeah. So the information gain is how much confusion or the impurity are present in the data. So information gain is again, oh, sorry. Yeah. So here information gain again depends on the entropy. So first we need to understand this entropy. So even in the interviews, people asking what is meant by entropy in the decision tree. So that entropy means how much confusion or the how much impurity your data have. That is you can find out by using entropy. And is it possible to directly can find? So let's say here in the society, people having the salaried people, all people are salary people. So this is you can say very pure. So some people are salary, some people are high, people are non-salaried. It's a less impure. Let's say all are mixed. Salary people are there, businessmen are there. So mixing of all the data is there. That's a little confusing. So that time the impurity is very high and you're little confusing. Your decision tree will confuse. So that's the reason first we need to figure out this entropy, just the impurity, the how much the mixing of the data is there, how much uncertainty of the data is there. So for that, we have a formula. So after making a lot of research, the people decide the one formula. This is the formula. So minus p log 2p minus q log 2 cube. So what exactly this means? See here, the p is let's say one class. So let's say people are applying for the loan. So eligible for the loan. These guys are S, these guys are no. Belongs to S class and no class of the target. Okay. So we'll take into consideration of them and based on that we'll figure out this entropy. Okay. The same thing we can do for the columns also. See here, the minus p log 2p and the minus q log 2. So what exactly the p is the let's say probability of class as positive class and the q is probability of class no other than the S class. They are like a negative. So I'm taking the logarithm of, so they have considered this formula log 2 of P and it will find the how much impurity is there. Let's see now. So, okay, fine, log. So entropy is fine. It is completely about the impurity. But what about the information gain? What does it mean? So information gain is it will find the how much the uncertainty or the impurity will be reduced after splitting. Let's say here you already have the root node and you're already putting the data. So then you are started splitting, right? You are started splitting. So after splitting, how much the impurity will be reduced, that is you can observe here. So that thing you can evaluate by using this information gain. So the same thing I have given here. So information gain measure how much uncertainty or the entropy is reduced after splitting the data set. Okay. So it figure out the best separating of the data. And you can say in another terms, so the best information which feature is giving regarding the my output. Okay, you can take it in that way. And the formulation wise, so the gain information gain is the so h of s summation of the all the values, and I'm considering this of v and the s of the h of sv. Let's see what exactly each and everything. So h of s is the entropy of the original data set where you have the root node all complete data set you are putting. That is the where you are finding the entropy of the root node. I'm finding the entropy here. I want to find entropy here also. I want to find entropy here also, right? Then only I can decide. So I will find the entropy of the each child node. Here I will find. Okay. Then what about this? This is the number of records of the child node and the total number of records also we are considering here. Okay. So this is the way this formula will be applicable and we will find the information gain. So first we will find the entropy of the each and everything, and then we'll find the overall information gain and how much this feature is giving um, the information regarding that. Okay, so let's say if it is the entropy value is 0, you can say the data is really pure, there is no confusion. Okay, if it is the entropy is 1, the maximum confusion is there. Because the lot of data is there and you can observe the lot of classes are there, lot of medicines are there, lot of things are included. And if it is in between the 0 to 1, partial impurity. So decision tree always took the feature, the important feature based on the highest information gain, means the low entropy. So the entropy will be high, the information gain need to be low. Or you can say in actual case, it is low, it is high. So both are inversely proportional each other. One is low and the another one is high. But generally, we need the highest information gain. Then that feature will gives the more information about the my target variable. Let's take one simple example. There is generally in the classrooms what happens in the while you are studying. So in the classroom, the many people are there, males are there, females are there, and different class sections are there. So let's say there are the 30 students are there. This is the one of the simple problem. So and there are the boys and girls are there, and these are the features. The class 9th and 10th students are there, and I'm going to in this problem statement based on the height also people are some people are play the cricket, some people are not play the cricket. This is the way 15 people are play the cricket in the 30 people. Okay, and how this decision tree will make the prediction on this, how who are playing, who are going to play the cricket, who are not play, and how exactly the splitting will be happening. We will make the simple calculation here. So let's try to understand this data. So I have the gender. So I have the class. These are the can say these are the features I have. The height also there, and this is my target variable. So they are play or not. They are playing the cricket or not. Okay. So here I'm just making the who. So in this problem, they clearly mention that how many, let's say gender wise, how many females are play. Total 10 female students are there. Two people are play. Remaining 8 people are not playing. The gender wise males. 20 students are totally there. 13 are play, 8 not play. So here, sorry, it's 7 people not play. So this is the way the height was also the 5 people are playing, remaining people are not playing. And the height was 10 people are playing and the remaining 8 people are not playing. The class, so 6 people are playing and the class 9th, class 10th, 9 people are playing. So, so this is our problem. Some people are playing, some people are not playing. This is the data set I have. So how the information gain and Guinea will be finding the best feature to make the splitting? Let's see one by one and clearly. So the entropy calculation at the parent node means the root node first we need to find the entropy, right? Then we'll find the child nodes. Then we'll find at the child nodes. We'll find at the child nodes. Okay. This is the process continuously happening. This is a continuously happening and ends with the result. Okay. So first we'll find it here. So how to find it? So let's total 30 students are there and the 15 students that play the cricket, 15 are not playing. So if I'm applying the formula here, entropy formula, I'm already explained in the earlier, the same formula I have applied, I will get the 0.5 for the one class and the play and the not play and the complete entropy for this complete one, I am getting the one. So you can take a calculator and do, you will get the one here. And but what exactly this one is, it makes a lot of confusion because it have the all the classes. It have the gender is there, gender data is there, class data is there, confusion, right? And even you have the height data also there, the height data also there. So this is the problem. So because of this mixed up data, you will get the one and you have the lot of impurity. Let's see how exactly this entropy is there in the child node. Remember that value, that is the one. Okay. So now I'm going with the gender. This is the column I am taken. So females 10 people are total are there and 2 people are playing, 8 people are not playing. So the same thing, I'm applying the entropy here. So same formula and the females. So 2 people are playing, 10 people are total. So that's a 2 by 10 and 8 not play and in the total 10 students. So I'm getting the 0.72 for the female one. Keep this value aside and same for the let's say total males. It's a 20 students are there and the 13 will play and 7 are not play. So same thing I have using here 13 with the play. So total students. So the same thing with here other class 7 they are not playing. So in the total 20 students and the 7 are not play. That's the reason you will get the male node at the 0.93 as the entropy. And if you want to find the complete gender, okay, the complete gender, what I what is the complete entropy for the gender is it's a 10 by 30 means we'll take the how many females are there, okay, and I'm going to calculate like a total females by total students into and find in making the into with the 0.72. Why? Because this is the entropy of the female node. And total male students are playing 20 male students are there in the total 30. And how many people are playing? Their entropy is 0.93. The value is 0.86 for the complete gender. So this is not good enough. Entropy must be, if it is high also fine, but we need to find the information gain. We already know, we have the formula. The entropy is like before the splitting and the after splitting. That is the information gain. So here I'm just, this value already I'm getting before. So this is the value 1 and I want to make the subtraction. So that's why 1 minus I'm applying the 0.86. I'm getting the 0.14. Just remember this value. I want to take the one more column and which column is the decision tree will make start the splitting. So I'm taking the class here. So in the class 9th, 14 students are there, 6 will play, 8 are not play. The total 16 are there in the ninth, and the 9 will play and the 7 are not play. I am applying the same formula here. The same, the 6 out of 14 are going to play in the class 9, and 8 out of 14 students they are not going to play. So in the class 9th entropy is 0.99. In the class 10th is it's also 0.99. The overall class split for the entropy of the class is it's a 0.99 again. So you can take the calculator and do. So you will get it. Okay. So not much about the calculation, but try to understand how the decision tree will do this part. Okay, internally. So entropy before split, I will have the 1, and the entropy at that complete class is the 0.99. So the overall information gain is 0.1. So I'm already told you, know, just remember this value 0.14, this value. And now here you will get the 0.1. This is the way how many features are there. The decision tree will find all the values information gain. So here for these two features, the gender is really giving the higher information and the class is giving the very low information. So then you can decide which is the best. Obviously, gender is the best information is giving about my target variable. So I will take this into consideration and I will start splitting from this gender. Gender I will selected the root node. Okay, what my point, guys? So then now I will jump to the Gini. So how exactly the Gini is working? See, two methods are there. Information gain is there, Gini is there. You can take any one of that based on the your problem and the data set. So let's try to understand what is mimic Gini and the Gini impurity. Both are interlinked, and the Gini impurity will be calculating from the Gini. So that's the reason I'm giving the so what is the mean by this Gini is the metric to measure how pure or impure of your data. So it will find the how much purity is there. And the formulation wise, the Gini is p square plus q square. It is the one class, is the another class. Okay. The people are who are eligible for the loan or who are not eligible. Let's say in the gender wise, how many people, the males and the females, right? Let's say here, then what is the Gini impurity? The Gini impurity is like it will find the probability of how much incorrectly classification is existing in your data. That thing you will find by this Gini impurity. Okay. So the probability of incorrectly classifying a randomly chosen data point, and it will measure the how much mixes are there in your data set. It will measure the impurity of the particular column. It will find the probability how much they're incorrectly classifying. So in the formulation wise, so the Gini impurity is the minus Gini. Okay. So let's see, we will do some calculation. So, and here I mentioned that here the lower Gini is the having the lower impurity. So the better split you can do with that column. Let's see. See here, the Gini impurity I'm applying on the gender and the class also. So I'm making the simple p square plus q square, whatever the formula already there for the female and the male also I'm finding why you are getting the 0.2 because you already have the data. So, so total 10 students are there and the total 10 students and the two people are playing and the 8 are not playing. So the similar fashion I'm making this. And here I'm finding the Gini of the complete gender. It is nearly 0.59. Then I will find the Gini impurity. This is the ultimate thing I want. So that's the reason I'm just making the 1 minus 0.59. I'm getting the 0.41. Remember this value. And here 0.43 for the class 9th. So these guys for the class 9, they play and these guys are not play. See, two classes every time, right? I'm applying on the two classes. And even with the class 9th also same, I'm getting the 0.51, 0.51, the overally, so total out of 14 students from the ninth class, from the all the students, I'm multiplying with the how many people are from the class ninth and the class 10th also. Many students total are there in the class 10th with the total students. So overall, I'm getting the 0.51. If I'm making the subtracting from the value 1, so before splitting this guinea is the 1. So 1 minus 0.1, it's a 0.49. You can see here, lower guinea of the having the data is so pure, you can easily make the splitting, right? So here the who's the winner is again the gender is having the lower Guinea. So obviously the Guinea impurity must be very low. Okay, this is a low and it is a higher value. So that's the reason. So you can observe both the methods will supposed to give the hey decision maker. You can follow to take this gender as the top priority, then you can go with the class. So this is the way you can do the splitting. So the decision tree will do the better feature selection and it will do and find the so which is the best feature to make the splitting. Okay, it will make the yeah, this tree really looks nice, man. All the stars and the branches, sub branches. So how exactly this decision tree is working? Let's see. The starting with the root node, the steps wise, when the training process, what internally happening is, first it will start with the root node. The complete data set I'm taking as the S, and then we will use the best attribute selection means column. Which column is going to I'm splitting. This is you can say ASM attribute selection measure, which is giving the more information. Here we have the two methods, information gain and the another one is the Guinea impurity. So both the methods we can use. We can use any one method. So based on that, we will find the best attribute or the best column to make the splitting, which is need to take in the top, then the other ones, and then we will start splitting out the data. So we're already get the best column. We'll start subsets. We will make the splitting of the data set, and that slowly decision tree will be building. It will generate the different nodes, right? And the top it is already there, and that in the below, and the child nodes are there. Slowly the splitting will be continued, right? And this process is continuously happening till getting the leaf nodes. So this is the way completely the decision tree will the fully trained by make this splitting and finding the best attribute and making the splitting. The existing data will be trained. So now if I am giving the new data, it is giving the result. So you're already trained, right? So then if you are giving the any new data points, it can easily find the this guy is eligible for the loan or not. That is the mail is spam or ham mail. Okay. Important mail or unimportant mail. That guy is having the risk of after 10 years getting any kind of issues with the health issues or not, a kind of BPs or sugars. You can make this kind of, if you are trying the such kind of data, you can make this predictions from this complete process. This is the way the training processor will be happening. And let's jump into the what exactly the way we are set up with the problem. I will take a simple code, not much hard or those not things. So generally in the weather reports, what happen is they will took the lot of columns into consideration and the what is the pressure at the some time and the temperature and the how the wind direction is there and the wind speed and this how the rain accumulation is the possibility and based on this they will find the humidity is higher not, right? Humidity is higher not. So this is the one of the simple problem I have taken. So this is my target. The humidity at the 3 p.m. is it high or not? High or not? High or low? So for that, first I will import all the libraries. So these are the steps generally people follow. First we will import the data set, then sorry, import all the libraries. Then we will load the complete data set and we will clean the data set also. So this is the daily weather report is the CSV file I have taken. Okay. And I'm just removing all the null values. For that, I'm using this drop now. After that, I'm just splitting my features, which are the my target variable I'm separating and who are the X variables, so the input features. I'm considering them into these features. These are the variables I have taken X and Y, and I am making the splitting here, train test splitting. So on the X and Y, on the X and Y. So the test size I have considered the 30% of data I am considering as the for the testing, and the 70 is like a training. So if you want to know about the what is mean by the test and train means, it's like a, let's say one student is preparing for the exams. So the complete exams like he is spending a lot of time in the semester, and that you can consider it as the 4 to 5 months they are spending on the lectures are giving. That is like a training, 4 to 5 months. The last they conduct an exam, right? So that result will be you will get from this test data. Okay. So that's the reason I will split the my 30% of the data into separate data, 70% of the data for the training. So let's see what is the next step is. So then I will train my model by using my data. Okay, here I'm applying the entropy. You can apply the Gini also. So here I'm applying the entropy and I'm giving the maximum leaf nodes. See, a lot of concept is there, but here coding wise, you don't know what is really happening. So I'm saying that the training steps complete hiddenly happen behind this happening by taking this entropy into consideration. From this, it will find the information gain, then it will start splitting one by one, and how many the depth need to be have the maximum leaves we can take this. So finally you can see the maximum leaves are the 10 predictors here. So that is your mentioning here, and the random state of the data will 0. So and I'm completely training my 70% of the data to the my decision tree classifier I have taken here. And if I'm evaluating my model, how much accuracy I am getting from this data after training my data. So I'm getting nearly 90% of the accuracy. Okay, fine. So what is the criteria I'm using here is entropy. So we need to mention inside the parameter of the particular decision tree classifier algorithm. Okay. So if you observe the coding ways, you have this parameter, and you need to mention the limits of the trees, the complexity. You can take the control by using this parameter to prevent the overfitting, and the random state is the 0. So just I am taking the whatever the data is there as it is I am taken. I am not applying any randomness on my data set. Wow, this is the final result you can observe if you are if my data, whatever the whatever the data here is there. So see here, daily weather report data is there. So after training, so this is the way it is trained internally. So by the beauty of the scikit-learn is you can visualize the what is internally happening also in the machine learning. That's the beauty. This is the way you can explain to your customer also. If they are asking how internally happen, can you explain? You can explain by using this, and you can understand also fast, right? So first we'll find the so firstly you'll taking the complete data set here. Okay, and first it will take it as this relative humidity at the 9 a.m. This is the feature. It will take into top. Okay, so we have the complete data set. After putting the complete data set, this is the root node, you can say, or the parent node. Then, if it is the less than the relative humidity at the 9 a.m. is less than or equal to 25, it is S. I will take the air pressure at the next one and the relative humidity if it is the false. Okay. And after that, if it is an S, relative humidity at 9 a.m. If it is a less, I'm taking this one. So every time I will find the entropy, and from that, so here the entropy one, that's the reason I'm taking this is the on the top. Okay. After that, so the entropy is the 0.64 and the 0.45. So higher information is given by this air pressure 9m is the more than this. That's the reason I'm considering this. You can see the 342 and the 68 are there. See, less than 918, 34, the 342 are there, remaining are the 68. This for the class 0. See, it's a humidity high or the it's a low humidity. So this is the way the complete splitting happening and the end point with the, see, these are the leaf nodes. These are the leaf nodes. These all are the having the further splittings. These are the decision nodes. We can say decision nodes. These all are comes under this. So wow. So we are considering the every time entropy. We find the entropy every time for the class zeros and the class one. All the blues are class ones and all the yellows are the class zero. So finally, the complete data will be trained, and if I'm giving any new data point now, it will make the prediction the humidity is high or not. So that's the complete thing. And now I want to give out the what is the pros and the cons of the complete decision tree, and the why people are when to choose this use on the based on the data set. So it is really the main advantages with this decision tree is it's very easy to interpret, easy to understand, and then now pre-processing is there, so you can easily handle the non-linearity of the data. So the data is not following the linearity also. You can take into consideration that that's really good. And the feature selections also you can easily build in by using these formulas, information gain and the beginning. The main disadvantage of this model is it is mostly prone to overfitting. That's one of the major problem with this. But lower. Now how can we reduce this? So how can we fix this by using maximum depth? We are not using this parameter, but maximum leaf nodes we are used. So you can use these things and instability sometimes. So because of the large amount of complex data, it make we not able to handle that. And that time it will be take a long duration to train the complete data set. And imbalance of the data set also, it is giving the wrong predictions. That time you need to make the balance of your data set. So the classes are, let's say the loan people are eligible for loan eligibility. Let's say 100 people are applying for the loan. 80 people are eligible. 20 people are not eligible. See, 20% the 80%, so what happen is it is mostly imbalanced data set, right? So this kind of data set, you can need to make the balance by using oversampling, then you can apply this model, then it will like accurately work. And that finally, the complete summary was, so now you're understanding the how trees, the splitting of the data recursively happening, and the pure subsets, how it is happening, you understand this. And the root node is always contains the feature with the highest information. Okay, wherever the highest information you are getting, that point where you are stopped splitting, and that is the root node where that feature you will consider that column. The information gain and the impurity determines the best splits. That is what you are understanding. And scikit-learn is the one of the libraries. The machine learning, all the algorithms, the algorithms and the different libraries will be they're coming out of from this. And it's very easy to code us and to find the accuracy also with giving the just very less lines of codes. Here I mentioned the 5 lines, but the very less lines of codes, you can find the accuracy of this model and you can train also. This is the way you can understand the any type of algorithm very clearly, step by step. And guys, if you have any doubts and queries, you can ask me for me to explain in the more in detail also. And subscribe my channel. And if you have doubts and queries, you can put it in the chat. Thank you. Thank you so much, guys. Bye bye.